Okay, I am recording this lesson in the middle of a thunderstorm. So let's hope that things go well. You might hear some thunder rolling in the background, and I might lose power in the middle of this if lightning strikes the wrong thing. So let's just see how this goes. This should be fun. This lesson is about causal statements and their support. So we're continuing our work in chapter 11. And we're continuing our work there then in inductive reasoning. And in our work on inductive reasoning, we are moving now to causal statements. Now, I need you to recall that causal statements are not arguments. Causal statements and arguments are two fundamentally different things. So we need to be clear about that as we move forward. The question for this section is this: how do we support, or how do we know that our causal statements are true? We see two things happen together and we say that one causes the other. And how do we know that that's true? How do we support, or how do we argue, or how do we reason to correct cause and effect statements? Now, to some of you, this is going to seem like kind of a silly question, but let me try to motivate it a little bit here. Whenever we assert a cause and effect relationship between two things, it's important to keep in mind that we don't actually see causation. What we see is one event followed by another event, but we don't see that one event causes the other event. For example, if I have a book of matches in front of me and I pull out a match and I strike it along the side of the matchbook and the match lights, we will be, I think, reasonably in a position to say that the striking of the match caused the match to light. But since we didn't see anything called causation, there's no thing called causation that goes sneaking through the forest or that sort of rears its head whenever causal relationships happen. We don't see anything like that. What we see is the match going along the side of the matchbook, and then we see the match lit. And we conclude that the one event caused the other event. But again, we don't see causation. So we're going to take then a closer look at causal statements and how we support causal statements, because it's typically the way that we know that one thing causes another is that they go together somehow, right? There are many who believe that, for example, the weather turning cold is what causes leaves to turn from green to the pretty yellow and red colors we see and then fall off the trees, because every time that the leaves change colors and fall off the trees, the temperature declines. Well, that's an interesting causal claim. It's actually false. But people are led to believe that it's true because the way that we discover cause and effect relationships is just by noting that two things go together. And so this section is about that. How can we know that? How can I tell you for sure that it's not the changing of the temperature that causes the leaves to change color and fall? How can I know that for sure, that that causal statement is false or that another causal statement is true? That's what we're here to look at today. So causal statements, basically, they're simple. They just state the cause of something. So here's a couple of examples. The floor is wet because the toilet is leaking. So here I'm just stating why the floor is wet. I'm giving cause and effect, and I'm giving you the cause for the floor being wet, and that is because the toilet's leaking. The second one, I itch because I got a mosquito bite. I am here now giving you, I'm explaining and giving you the cause for my itch. And of course, as I say this to you, here I am itching my arm, because whenever we talk about itching, it just makes me itch. I think talking about itching causes me to itch. How about that? It's another causal statement, right? In each of these cases, I'm making causal claims. Now, remember, if we reverse these are not causal claims. If I make the claim the toilet is leaking because the floor is wet, now I'm not trying to explain anything. I'm actually attempting to support something or prove something. And so what I'm giving here is not a causal statement, it's actually an argument. The same with if we switch I got a mosquito bite because I itch. I'm not trying to explain why I got a mosquito bite. I'm trying to support the idea that I got a mosquito bite. I'm trying to prove to you that I got a mosquito bite, and the reason I think I did is because I itch. Notice again here that each of these claims, the one in red and the one in green, they make the same two claims. They just alternate their position around the word because. So I itch because I got a mosquito bite. I got a mosquito bite because I itch. But one will function as a causal claim and the other will actually function as an argument. So the ones that are not causal claims are arguments. All right. So now the question will become, how do we know that causal statements are true? That's the question that we want to ask. People make causal claims all the time. We see two things or more things going together a lot, and so we'll say that one caused the other. Okay? So how do we know that these causal claims are true? Again, we don't see causation. So there's nothing I'm looking at that says, oh, look, there was causation, so that must cause that. All I see is one event followed by another event, and from seeing or noting these series of events, I infer a causal relationship between the two. So now, if that's the case, how can I know that the causal statements are true, and how do we reason to the conclusion that A, for example, caused B's, right? How can I reason to a correct causal statement about what causes the leaves to change color and fall off the trees? We know now that it's not cold weather, but for a while, because cold weather and leaves changing and falling off co-varied because they went together, we would assert that one caused the other. We actually, through science, know that they don't. How did science establish? Well, sciences and all divisions of study that deal with causal relationships and causal hypotheses, or causation, start with forming causal hypotheses. So the first step when you're going to reason about any cause and effect relationship is to develop a causal hypothesis. Now, an hypothesis is just a guess, right? So we are not saying that we know for sure, but we're going to hypothesize what the answer is. So a causal hypothesis is just a causal statement offered for further investigation or testing. This is a guess. Now, often it will be an educated guess. We're not just like being random about it, but we're offering something for testing, okay? So these statements that we gave here about the floor being wet because the toilet's leaking and I got an itch because I got a mosquito bite, these statements could very well be offered as hypotheses, that is, things to be tested rather than as claims. So if I say I itch because I got a mosquito bite, and we look at my arm where I itch, and there's no red bump, there's no hole where a mosquito was, there's nothing, it's not even red, then we might show that my causal hypothesis is false. If we think that the floor is wet because the toilet's leaking, which, you know, in a real world scenario, I was sitting on the first floor, I have a two-story home, and I was sitting on the first floor, I saw a wet spot showing up in the ceiling, and I immediately assumed that my sink or the toilet or the shower, which is right above it, had a leak. That's a causal hypothesis. And interestingly enough, it turned out that it wasn't that. There's a 2-inch pipe that comes out of your roof. It's a vent tube for your drainage system, basically. And the seals around that had come loose, and so water from rain was actually getting in there. So again, this is just a causal hypothesis. Well, what are the different methods that we use for forming causal hypotheses? How do we know what's a plausible causal hypothesis? Why, when I saw the wet spot in the ceiling, didn't I say, hey, the dog peed up there? One, because it's implausible. Right? So how do I avoid utterly implausible hypotheses for causal relationships? Well, there are 3 that are mentioned in the book. Okay? They're a little bit difficult to sort out in terms of their difference. So I'm going to try to walk you through those and give you ways to tell the difference between them. Okay, so the first one is what we call paired unusual events. Now the name is very, very suggestive of why it's called that, so pay attention to that title. With a paired unusual event, what we're doing is that we're noticing that something new has happened. There's a new event, something out of the ordinary, something unusual has happened. Okay? And because something unusual, one particular thing that's unusual has happened, I look for something else unusual that has also happened. For example, let's say that well, let's see, I think we'll have an example in the lecture, so let me just, I have an example in the slide, so let me not try to make one up here. So the paired unusual events is this: if something unusual happens, now imagine everything's going normal and then boom, something unusual happens and you go, what caused that? Now you're going to look for something else unusual that happened that would have caused that. Okay? Everything is normal, everything's going good. Wow, that's unusual. What else is unusual? What other particular thing is unusual that may be the cause? So here's an example. As soon as my throat got scratchy, I got scratchy, it got itchy, I took Zicam. My cold went away faster than usual. Maybe, perhaps, Zicam caused it to go away. Now, here's what we're noticing. I took Zicam, I had an itchy throat, I took Zicam, my cold went away quick. Okay? Paired unusual events. The itchy throat is unusual, the taking of the Zicam is unusual, and it going away quick is unusual. So we're pairing the taking of the Zicam as unusual and it going away quickly as unusual, and saying that those two unusual events have a causal relationship to one another. That is, taking the Zicam caused my cold to go away faster. Okay? But again, we're noticing something out of the ordinary. So I got a scratchy throat, and now I'm going to take Zicam, and I've never taken it before, but I'm going to take Zicam. Boom, and I take it, and then something else happened that's unusual. My cold went away unusually quickly. Paired unusual events, and it's usually a single event or a particular thing. Okay? That's different from what they talk about in the book, where they talk about common variable principle. The common variable principle basically points out that there are a number of instances of something. That something happens a lot, not just one particular one. Like when I got the sore throat in the last example, like I get the sore throat, I get the itchy throat, and then I take Zicam, and I've not taken Zicam before. That's an unusual event, and I look for another unusual event. With the common variable principle, what happens is there are several instances of something, and you start wondering, well, what's causing that? For example, I had a Saturn that I drove for years, and that Saturn ended up with a particular problem. The air conditioning would not work I could turn it on. The compressor was working, but the fan wasn't working. And it would not work unless I made a left turn. Now, every time I made a left turn, my air conditioning worked. Okay? There is a common variable principle. That is, there are multiple occurrences of me turning left and multiple occurrences of my air conditioning turning on. So turning left causes my air conditioning to turn on. Now, I'm going to further ask why that's the case, and I'll need a cause for that. But the correlation between my turning left and my air conditioning coming on, because that's several instances, every time I turn left, my air conditioning comes on, or most of the time I turn left, my air conditioning comes on, I'm using common variable principle. Okay, it's not a particular instance, it's several instances. So this method of developing a causal hypothesis will be recognizable by the fact that there are multiple occurrences of something to be explained. Several people get sick, and we look for something common to all of them, something common to all instances of it. So I'm sorry, but I'm talking about the example here. So let's look at the example. When several people in Kearney complained to their doctors about acute intestinal distress, health officials investigated and found that all had eaten tacos at the county fair. So what we're doing is we're saying, God, there are a number of instances, several instances of people getting sick. What's common to all of them? But again, not a particular, not a single, but a common occurrence. And we're looking for something else that goes with it. We're looking for something else that is also common to all of them. Okay? The third and final one is called covariation principle. Okay? Now, we use covariation principle. Here's the definition. If a variation in one phenomenon is accompanied by a variation in another, the two phenomena may be causally related. So another way that we might develop a causal hypothesis is if we have something that we're observing that varies, right? It shifts, okay? It sometimes occurs this way, sometimes occurs that way, and it's not constant. So it's not like before where we had normal status and then something unusual happens, or where we had every time this happens, that happens. Here what we're looking at is something that's constantly changing, right? And then we're looking for something else that changes with it to explain it. So this is where they vary together, where two things vary together. Let's look at the example. Over the past few years, online instruction has increased at Memphis States, I'm pluralizing that. GPAs have also gone up. Perhaps the increase in the GPA was caused by the increase in online instruction. What they're saying is, gosh, there's been this consistent sort of changing, this moving up, this increasing of GPAs at Memphis State, and that goes along with an increasing in the number of online courses. So because they're both sort of creeping up together, they vary, but they vary together. One causes the other, okay? So those are the three ways that we might develop a causal hypothesis. There's the thing of thunder. Develop a causal hypothesis that needs to be confirmed. Again, this is about how to establish a causal hypothesis or a causal guess, and to make sure that our guess isn't completely out of the blue, that it isn't completely random. We use these covariation principle, the common variable principle, or the paired unusual events principle as ways to sort of zero in on things that are good, plausible candidates for a causal explanation. Now, beyond that, we'll have to do a cause and effect experiment, but that will be the lesson that we cover in the next lesson. That'll be what we cover in the next lesson. The final point here is about weighing evidence, right? So let's say that you go out to start your car and your car won't start. And I'm using the example from the book here, right? And once our car won't start, we've got an unusual event. It normally starts, right? So we've got an unusual event, not a bunch of events, and not a varying event. This is a single event. So we're going to look for, because of that, we're going to use the paired unusual events method for developing a causal hypothesis, right? So now I'm going to look for all the other unusual things that have happened that go along with the fact that my car won't start. So my car won't start, that's unusual. What else is out of the norm or unusual? Well, wow, I got a big typo in there. We had funny clicking sounds when we tried to start it. That should be we heard funny clicking sounds when we tried to start it, like if the battery were almost dead, right? If your battery's almost dead, you try to turn the engine on, you're click, 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 right? That's an instance of paired unusual events. Well, something else is that when we were trying to start the car, we smelled gas fumes, right? Like when the engine is flooded. And something else is, I also tried a new brand of gas. I normally go to Myers for my gas, and this time I went to BP for my gas, right? And you know what else is weird? The steering wheel won't unlock. Maybe those are related somehow. And you know what? It is really cold out right now, so maybe that has something to do with it. Oh, and something else. I just put in a new radio. My old one had a tape deck, and since no one on God's green planet uses a tape deck anymore, I updated my radio to a new one. Now, all of these are using the method of paired unusual events. All of these are potential hypotheses, but some of you will recognize that we've got to weigh the evidence for each of these potential causes, right? For example, the fact that that you could smell gas fumes and that you tried a new brand of gas. If you're familiar with working on cars and why cars don't start, that's potentially significant. That's potentially important, but that evidence won't weigh as much as the evidence that you heard the clicking sound when it failed to start. That is your most likely explanation that the battery is almost dead. And that might have something to do with the fact that it's really cold out as well, because when it's really cold out, batteries that are weak, your engine takes more energy to start it cold, and if your battery is dying or almost dead, and it's really cold out, that will accentuate, or that will exacerbate the situation with a dying battery. So some of these potential hypotheses are more plausible than others. Now, how can we know which are going to be plausible and which aren't? Well, you know, experience gives us a lot of that. If you work on cars a lot, then you'll have intuitions based on prior experience. I tend to work on all of my cars, and so if I had a car that didn't start and I heard the clicking sound, my first guess would be the battery, and that's the first thing that I would test. My guess is that putting in the new radio wouldn't have a whole lot to do with it, unless potentially that new radio is somehow drawing a lot of amperage and too much for the car battery, but that might just indicate more that my car battery is weak. The new gas, I really wouldn't consider that a major issue right off the bat. Now, if I went and put jumper cables on the car and it wouldn't start, and I might consider the gas, but the fact that you had a clicking noise, if it were the gas, you wouldn't even get the clicking noise. It would just get like a turnover, but it would not catch. So these are all things that we learn by experience, right? But notice too that cause and effect, think about, and this is in your book, but this is a really important point. This is one I want to draw for you here. Think about a doctor who is, let's say she's got a patient before her who gives her a whole bunch of symptoms. your doctors have to decide which symptoms to pay attention to and which symptoms not to pay attention to. They're looking for, if you come in and you're sick, that's an unusual event, and they're going to ask you for other unusual events to go with it to try to diagnose it. And that pairing of unusual events, again, that your doctor will be using paired unusual events there, their expertise, their studies help them in weighing the evidence to know what's important to weigh and what's not important to weigh. So that is a part of that as well. I just wanted to be clear about that in the last part of this lesson. So, but anyways, that's causal statements and their evidence and how we might draw causal hypotheses. So in the next one, we'll work more on how we actually confirm causal hypotheses. So there we go.